just so I have a separate recording for the other chapter. All right, so this is starting the Net Plus chapter, Communication and Network Security. So, Simplex Communication is when you go just one way, like a radio. All you can do is listen, you cannot transmit at all. Half duplex is like a walkie-talkie. You can talk, but while you're talking, you cannot listen. And you can listen, but while you're listening, you cannot talk. So people have to take turns. And the most common, like a modern telephone, is full duplex, where both people can talk and listen at the same time. Baseband is where the entire frequency range available in the device is used by one signal. This is Ethernet. Every computer on an Ethernet network has its own wire, and it's able to use the entire bandwidth of that wire for one computer. The radio signal, like Wi-Fi, is broadband, where there's multiple channels and multiple devices using it at the same time, and they each get only a range of bandwidth. Analog is a signal like AM or FM radio, where it is just where the music gets louder, the signal gets bigger, so it's just following the signal, and therefore every time you transmit it, the signal degrades. Every time you copy it, the signal degrades. This is like the old vinyl records, where there are certain high-quality records, and the more you play them, the more they degrade. Digital signals are the modern ones, where everything is encoded with ones and zeros, and even though the transmission is not perfect, and the storage is not perfect, you have error correction, like checksums and such, so you can detect errors and retransmit the signals that get damaged, so you can achieve 100% accurate transmission and copies that way. A local area network is the network in a building, metropolitan within a city, and the wide area network is something big. There's a global area network, and then there's a personal area network, which is the things you carry around, like the Bluetooth between your headphones and the earpieces and your cell phone. The internet is the global collection of networks running the TCP/IP protocol, and an intranet is a privately owned network inside a company, including only the authorized company employees and perhaps your business partners that you have authorized, but not public to the whole world. And an extranet is something that connects private intranets together. Circuit switch networks are where you get to use an entire cable just for one transmission, and you have to first make the connection. This is the way long-distance phone calls were back in the 40s. Almost everything is now a packet switch network, where you have many different transmissions sharing a wire broken up into packets like cars, so many things are traveling down the same wire, broken up into little packets and addressed so they can be routed and reassembled at the other end. This allows much more transmission down the same wire because many signals share the same wire. That's why almost everything is done that way. VLAN, VLAN is a virtual local area network. It's a tag put on things to make devices act as if they were all in the same room when they aren't. But it's not on that previous chart because a VLAN is not a measure of how big a network is. It's just a detail of how you address the frames. A very good point. So quality of service is a feature that allows you to mark packets, so some packets have a higher priority than others. Packets that make something like a web page or an email can be delayed, and it doesn't really matter, but packets for something like this streaming video I'm using now, or a voice connection, if they're delayed, it causes a chatter and makes it hard to understand the speech, so you have to give those a higher priority if you want to get the most benefit from your network. So all these devices work from a layered design these days in order to make it possible to manufacture a lot of equipment and have equipment from different manufacturers work together. There are layers, and you specify what layer your device works in. So you can have different software and hardware devices to operate at the different layers. There are two common network models, the OSI model from Europe and the TCP/IP model, which I think came from America. The OSI model has 7 layers, the TCP/IP model has 4 layers, and they both describe pretty much the same thing. And a network stack is a whole bunch of protocols specifying how you will move data across the network. And TCP/IP is the most important one for us because that's the one that runs on the internet. So this is the OSI model. It has 7 layers, from the physical layer up to the application layer. And there are mnemonics here. Please do not throw sausage pizza away, or all people seem to need data processing. To memorize these, you have to memorize them, you have to know them. So the physical layer is the wires or radio signals. The data link layer addresses packets with MAC addresses. The network layer moves packets to the physical computer you're trying to reach over the internet using IP addresses. Then the transport layer runs TCP and UDP and has port numbers so you can find the correct process on the server you're trying to reach. And the session, presentation, and application layer all process the data to make it readable and understandable by a human, and in practice they're all usually combined into one piece of software like your web browser. So that's the point. The protocol data unit at the physical layer is a bit. That's what you call it. And these are the physical media that carry signals. Things like hubs, cables, and repeaters are all just physical connections to connect one device to another. The data link layer has MAC addresses, so it transmits data on your local area network, and it goes through switches, which is a multi-port bridge, out of your Ethernet card to deliver those packets on your local area network. Then if you want to go out of the room, you go up to the IP layer, and there's 2 sublayers in a data link layer, MAC and logical link control. They're both included in your Ethernet card. The IP layer, network layer, is where you actually find the geographical location of the computer you're reaching, and it gets routed over the internet. So this is using IP addresses of either the older IP version 4 or the newer IP version 6, and routers, which are what form the backbone of the internet, to move it physically across cities and continents until you get to the right device. The transport layer is almost everything is TCP or UDP here, and they have port numbers. TCP is by far the most common one used. This numbers packets. It is reliable. It has a handshake to make sure that the device at the other end is receiving it. It has error correction. It has ordering, so you can send a lot of pieces and reassemble them at the other end. So it is like sending mail with return receipts on it. It therefore is more complicated and slower, but more reliable than UDP. UDP just sends the packets and does not detect if they get lost or rearrange them if they get out of order. But under normal conditions, they mostly all get there in order because nothing changes on the transmission line during transmission. But if something does get lost, it's just gone. The session layer establishes some kind of connection and remembers who you are for a while, so you do something like log in to something like a network share, and the session layer is the layer at which it remembers that sort of information. You have a connection. And the presentation layer is what does things like convert the data from binary to a viewable form, or decrypt it or decompress it. And then the application layer is what lets a human see it. So it presents it in a way it means something to a person, like an email client or a web browser. And so the protocols you see commonly in like the URL of a web browser are application protocols up at the human level. So, does anybody have any opinion whether we should try these cahoots, or is it too difficult? Let me look up my pings and see if I have any clue. Looks like the network's working pretty well now. I think we should try the cahoots, unless I see some protests coming by. Let's try them. I will, however, lengthen the time on them. Good? Okay. This is 4A. Let me lengthen the time on it, because I think there's no chance of getting away with just a 30-second time limit. All right. So it's 4A. Okay, good. From my ping test, it looks like the network's actually working pretty well right now. Yes, that's the thing, Dodan. It rates you both on accuracy and speed. Although, especially under these kind of network conditions, I'm not sure that everybody is seeing things at the same time. It might not be totally fair, which is one of the reasons why I made it all extra credit. It looks to me like the delay has gone down. I'll give it a few more seconds to see if somebody else is joining. Apparently not. 1, 2. All right, so what transmissions go through an Ethernet cable? The delay is much better. It's under 10 seconds now. Good. Huh. When I get 8 answers, it ought to quit. If there's only 8 students, well... Oh, there's 9 students. Good. Okay. Anyway. All right. So that's baseband. That's what that's called. Not half duplex. It goes both ways on Ethernet. All right. Where do you see MAC addresses? Good. I figured out who VoIP was. Okay, that's it. Layer 2 is where the MAC addresses are, the data link layer. Okay, what layer has hubs? All right, that's layer 1 at the physical layer. All right, how about network file shares? All right, that's up at a high level, above all this addressing stuff. All right, layer 5 or 6, I think. So Serge, okay. And Judah. right, I don't know who that is. Okay, so I'm gonna